Okay, step 3 is to determine, after determining null and alternative hypothesis, the next step is to calculate the data summary called a test statistic. That measures the difference between the sample result and the null value. The test statistic for a single proportion is that formula. Yes, you will be given that formula whenever you get the second half of the stuff. So test, I don't remember if there's a quiz over the second half or not. I think there is. The test statistic for a single mean is this. Now, it's still just, the top is p hat minus p over standard error. It's just standard error. It's giving you the whole formula instead of just standard error. Same thing for the bottom one, okay? Then you compute a probability called a p-value. Now, we are only going to compute the p-value for z. It's more complicated for t, and so we're going to do it a different way. But for z, if you're given the z value, you're going to go calculate the probability using the z chart, just like we've always done. P-value is the probability of getting a value of the test statistic that's at least as extreme as the test statistic obtained from the sample data, assuming the null is true. Remember, we assume the null is true until it's proven false. You are assumed innocent until proven guilty, okay? Okay. So here's where you have 2 step 4s and 2 step 5s, depending on if you're using the p-value or the test statistic. So if you're using the p-value, in a hypothesis testing, the objective is to decide if we should reject the null hypothesis in favor of the alternative hypothesis. You are proving the alternative right or wrong.
Which proves the...
Which either you reject null or fail to reject null. We do this by comparing the p-value to a designated standard called the level of significance, which is called alpha for the test. If p is less than or equal to alpha, we can reject the null. If p-value is greater than alpha, we fail to reject the null. Following memory device is useful for using p-values. If you want to use the rhyme, use it. If the p-value is low, then the null must go. So you reject it. If the p-value is high, then the null must fly. Personally, I just think that the rejecting one makes sense. The other one to me does not, but that's sort of their little memory trick for it. But if the p-value is low, the null must go. So we reject the null. Otherwise, we don't. Okay? So it's this or this. It makes it a little bit easier. The details of how to find p-value depends on the direction specified in the alternative hypothesis, if it's right tail, left tail, or two-tailed. So we'll have to go through each of those when we start working on examples. For a less than alternative hypothesis, find the probability the test statistic could have been less than or equal to what it is. That should make sense. Less than, less than. For greater than, find the probability the test statistic could have been greater than or equal to. For two-tailed, you find the probability the areas are in both extremes. And again, I think this makes more sense once we start doing examples, okay? So here's a visual of what you're doing. Left-tailed test, that's your probability that's shaded. For a right-tailed test, that's your probability that's shaded. For two-tailed, it splits it in half, and so you're looking at both of them. Does that make sense? Yeah? Okay. When you calculate the p-value and draw the picture, the p-value is the area in the left tail, area in the right tail, or split evenly. So that's all that. Okay, so step 5A, make a decision based on the p-value. So this is what we were just talking about. If p-value, is less than or equal to alpha, we reject the null. If the p-value is greater than alpha, we fail to reject. So that's stating what we just stated a minute ago as well. The level of significance alpha is chosen by the researcher before the experiment or study begins. So obviously you're going to be biased if you do the research and then decide alpha. So alpha is determined before. Alpha is the level of significance. Thank you.
And that's how strong the data is?
No.
Or the,
Think level of confidence type thing. It's that level of significance is determined.
the higher it is, we reject null, the lower it is, we accept null.
If P is above the A, then we accept null, right?
If the p-value is less than alpha, we reject the null. If it's greater than alpha, we fail to reject.
That's what
Okay, you said it backwards.
if P is greater than alpha, I
Wait,
said
what
we
is
fail
alpha?
reject.
Okay, I didn't hear you say fail, I just heard you say rejected. So, okay. If alpha is not given, use the default alpha of 0.05.
Oh, but so we don't have to solve for alpha?
Nope, you don't have to do anything. Either you use what's given in the problem of alpha or no, alpha is 0.05. Yeah. There's no solving on that one. That one's kind of a given. The phrase statistically significant is used to describe the results when the researcher has decided the p-value is small enough to decide in favor of the alternative. In other words, you reject the null. So you will use, when you're stating your conclusion, you're going to use the phrase statistically significant. Step 4B. So this is if we're using this test statistic, not the p-value, okay? So before we had all the technology, calculator, all that stuff, researchers used a method called the rejection region approach. The critical region or rejection region in a hypothesis test is the region of possible values for the test statistic that would lead to rejection of the null hypothesis. A boundary of rejection region is called a critical value.
Which is our Z stuff, right?
That is Z star, that is correct. The critical value is denoted as Z star or T star. When we're using Z star, we're going to be for the proportions. We won't use this though, we'll use probability. So this is similar to what we found when computing confidence intervals, while the rejection region is the area more extreme than this value. If the test statistic is in the shaded region, which is the rejection region, you reject HO. That should make sense. If the test statistic is not in the shaded region, you fail to reject. So that should make sense. It's the same as the probability as well. Like it all kind of matches, okay?
So you're just finding probability and finding out if it's...
You're not finding probability on these. You're using the Z values. And again, I'll walk you through these. It'll make sense. It's very similar. It's just you're using two different values. And then when you're using p-value, you're using alpha, whereas this you're using your Z value that you solved for with those equations I gave you on the first page of the notes, the test statistic, and then you're using T star or Z star. So that's the difference.
I assume a lot of this test is going to be like comprehension versus computation.
No, it's going to be both.
Really?
Yeah. The comprehension was like the first, the computation is like the last part of the chapter.
Okay.
So it's sort of split in half. Okay, the p-value method and rejection method give equivalent conclusions. It does not matter which method you use. You will get the same conclusion no matter which way you use, okay? Possible decisions, we reject the null hypothesis or we fail to reject the null hypothesis. Remember, we never accept the null hypothesis. We do not know that something might happen in the future that can prove the null wrong. So we cannot accept it. We can only fail to reject it. Okay? And again, the criminal trial. Consider a criminal trial. The process is the jury obtains information, sample data. The jury then deliberates about the evidence, the data analysis. The jury either convicts the defendant, rejects the null, you are guilty, or declares the defendant not guilty, fails to reject the null. They never declare them innocent. So again, follows the same line of logic. So if you get confused, go back to that thought, because I think everyone in here understands that process. So go back to that thought to remember, okay, it's not we're accepting the null, we're rejecting it or failing to reject it, okay? Just like in a court of law, more evidence may come through later that shows that they are not innocent, which is why we never declare innocence. We never accept the null because we might have more data later in another study that shows that that null is false. State your conclusion. If you reject H naught, there is no sufficient evidence to conclude. Sorry, there is sufficient evidence, I said the wrong word, to conclude whatever your alternate hypothesis was. Also, we will use that phrase statistically significant in there as well. If you fail to reject, there is not sufficient evidence to conclude the statement in H1.